Open to section 3.4 in your packet and go ahead and take a look at the warm-up, and I'll let you pause the video while you work on that. Okay, so for 82, using the quadratic formula or completing the square, you should have gotten -2 plus or minus root 5. And 83, same thing, quadratic formula or completing the square, you should have gotten -2 plus or minus I root 2. And I'm going to go through 84 with you. So here's what we've been given, and that f of 3 equals -150. So that means that when x is 3, y is -150. So you want to plug in -150 for y, or f of x, and you want to plug in 3 for x. So then this is 81 minus 3 minus 27 minus 4. So we've got -150 equals an times 50. Divide both sides by 50, and an is -3. So this is not in your notes. I just screenshotted this from your book, but I just think it's a good idea to kind of lead into this lesson, to look at what it means to find the zeros of polynomial functions. Basically, anything goes. We could get real or non-real answers. So the way this looks, it's factored, but it looks different than the factoring you're kind of used to. Anytime you have imaginary solutions, then there will always be two of them, a pair. They always come in pairs as conjugates. So if you have 4 minus 5i, then you'll also have 4 plus 5i. So that's just true for imaginary solutions. So yeah, just to give you an idea of all of these possibilities for zeros. Now this is in your notes, and what this is basically saying is that all of the possible zeros, and this is just possible zeros, but when you're trying to find the zeros of a polynomial function, I want you to write down that it's the factors of the constant term divided by the factors of the lead coefficient. And if you read this, that's what they're saying. So you look at the constant term, find those factors, look at the lead coefficient, find those factors, and then divide them in all the possible different ways. And so let's take a look at that on example 1. Looking at the solved problem, you can see how they listed out the factors of the constant term. So here's the constant term, -3. And so the factors are plus or minus 1 and plus or minus 3. And then factors of the lead coefficient, which was 4. So here are all the factors of 4. Okay, so we've got the factors of -3 over the factors of 4. And they do this kind of funny way of writing it with commas, but really it just means you've got to do all the different possible combinations. So like plus or minus 1 over plus or minus 1, and then plus or minus 1 over plus or minus 2, and plus or minus 1 over plus or minus 4, and then plus or minus 3 over plus or minus 1, plus or minus 3 over plus or minus 2, plus or minus 3 over plus or minus 4. And that's how they're getting all these different fractions. Okay, so I'll let you pause it and try the pencil problem, and then I'll work it out. Okay, so the factors of 6, which is our constant term, we have plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And then the factors of the lead coefficient, 3, would be plus or minus 1 and plus or minus 3. So I'm going to do that 1 over 1 is plus or minus 1 over plus or minus 1 is plus or minus 1. Plus or minus 1 over plus or minus 3 is plus or minus 1/3. Plus or minus 2 over plus or minus 1 is plus or minus 2. Plus or minus 2 over plus or minus 3 plus or minus 3 over plus or minus 1. Plus or minus 3 over plus or minus 3 is plus or minus 1. We already got that. Plus or minus 6 over plus or minus 1. And plus or minus 6 over plus or minus 3 is plus or minus 2. And we already got that. So these are all the possible, and let me emphasize that, all the possible rational zeros. These are not all the zeros. These are just the possible ones. Number 2. And this one continues on the next page. Okay, so here's what we do with that information that you learned how to find on number 1. We find all the possible zeros, and then what you do is you use synthetic division to find one of them that is actually a 0. So you just, here where they only had 2 possible zeros. If you look in the book, you'll see how they test all the different zeros, but anyway, 2 works. If you do synthetic division, you get a remainder of 0, which means that x minus 2 was a factor. So that was a theorem from 3.3. So what that tells you is a missing piece of the puzzle. That means that x minus 2 times what this would be is x squared plus 3x plus 1 equals 0 is another way to write this function. So it's factored now. So we know one of the zeros is 2. Now we need to set this factor equal to 0. And since this trinomial doesn't factor, we do the quadratic formula. And they come up with this. So our zeros are 2 and then these 2 real rational numbers. So these are all real zeros because we're going to get imaginaries here in a little bit. These are all real. Not rational. I started to misspeak there. That's not rational. But these are all real.